see if we can get Sasha in here. So while we are waiting for Sasha to join, looks like it's connecting. Yes, Sasha, we've got you. Second time's the charm. Welcome along, buddy. How are you?
Yes, the Google Pixel wins.
Got there in the end. So I guess a lot of our followers may not have heard of On Point Dyno or Mountain Pass Performance. So we're going to have some questions here. We've got already a bunch stored up from our story that people have asked that I'm going to put to you. But for those who are watching live right now, can you maybe give us the 1 minute sort of abbreviated version of your history in cars? How'd you get started?
Oh yeah, that's always difficult. I'm not much of an elevator sales pitch guy. Long story short, you know, like a lot of us when we were kids, just not very good at anything except for cars. Loved cars and started going racing with my own S14. Kind of always been a Japanese car guy. And it's evolved over the years and dyno tuning and running race shops and doing some professional racing around North America. And now we're focusing on electric car performance. And we've done a couple EV conversions and we make parts for the Tesla Model 3 and some other electric cars now.
You've had like quite a large pivot with your business because you're really well known for your Nissan 350Z, which I want to talk about because you've done some incredible changes of direction with that as well. But more recently, you've sort of shifted and pivoted towards EV performance with Mountain Pass Performance. So, I mean, this is an area that a lot of us who are passionate about cars are maybe struggling to get their head around this shift that we are seeing towards EV. So what kind of convinced you to jump on the EV bandwagon so quickly?
That was a couple of years ago now, but I remember thinking the performance that Tesla was making out of electric cars was really impressive, and thinking that you know, electric cars could be really cool as a daily driver. You know, from an environmental standpoint too, there was a factor there. And it was a technology I didn't understand much about at all. So I kind of just impulsively bought a drive unit on eBay one day and figured, well, we've got to put this into something, you know, kind of just to start learning. You know, that's how a lot of us learn, right? It's just by doing things. So that was it. Just kind of had the idea and got after it.
So that was your Blue Lightning build, which was, if I'm right, it's a Lotus Evora, is it?
Yep, exactly, right.
Okay. So, like, just from a technical standpoint, what are the challenges that you face when you buy, if I remember correctly, was it a crashed Tesla, basically the electric motor out of a crashed Tesla? What are the challenges of then getting that into a Lotus Evora? And more importantly, actually making it all function?
Well, when we did that swap, we were like the second or third people to swap in a Model S drive unit. So we didn't really know how we were going to control the factory electronics. That was the main hurdle. The rest of it had been done before and it wasn't impossible. I mean, there's a lot of fab work there, not too different from doing a normal engine or subframe swap. And then the main thing was just the scary, you know, fear of this high voltage and all this stuff that you've never touched before and you don't really understand. So that was really the scary part. I mean, it would almost be like, you know, when you first got into cars and then someone tells you you've got to do an engine swap on a, you know, some chassis, put an LS on some chassis that, you know, you're going to wire it yourself and you don't even know, you don't know what anything is. That's kind of what it felt like. We didn't know what contact, like there's all these new things, you don't even know what they're called. And you just know if you touch the wrong two things together, you're going to die. So,
yeah, I guess it's not often that happens with an internal combustion engine.
Right. Yeah, unless you somehow light a gas tank on fire, you're pretty safe.
Yeah, totally. All right, so in terms of the electronics for control, so I mean, this is an area that I'll be quite honest, I'm still not fully up to speed on the way the electric vehicles operate and the way the motors are controlled. So can you talk to us a little bit about how that sort of works? And I mean, I know that you're writing your own code in Motec's M1 build to allow it to pretty much do whatever you want. So talk to us about that interaction, or how it all works together.
Okay, so what we're using the Motec for is basically a vehicle control unit. So we're not directly controlling the motor, if you will. There's always an inverter in there that's been designed to do that job. So basically the vehicle control unit has to manage the high voltage systems. So it's got to basically flip the switches for the high voltage. It's got to manage the torque requests for the motor, all the traction control, looking at the battery, doing the battery management, high voltage charging, like DC charging, where you would plug into a supercharger on the side of the road type of thing. It's got to do all the communication protocol for that sort of thing, all the cooling, running pumps, and moving valves around. In the case of the Lotus, we've got a few different cooling circuits there. In the case of the Z, obviously it's also controlling the engine, so there's all the integration between the engine and the electric motor and the gear shift and all those types of things.
Yeah.
So that's the main function, and the main kind of, it's more of an integration project than anything. You don't really need to use something like that if you just want to get it plugged in and just get driving. You can just wire an accelerator pedal to a lot of these inverters and they'll work. But it's kind of rudimentary, and it doesn't give you, it doesn't give you the integration with the other units. So you kind of have all these different black boxes that don't talk to each other when you go that way.
Sure. So the inverter really is the key to this, though, and the inverter is matched to the electric motor, from what I understand. So it's basically controlling.
Sometimes, sometimes. So like in the case of the Tesla, they've got an inverter built into the drive unit. So there's an inverter on one side and a motor on the other side. But in the Z and a lot of other aftermarket applications use an aftermarket racing inverter, and those you can characterize the motor you want to use it with, and it's not too different from setting up an ECU for an engine. You just change the parameters as needed, calibrate kind of the crank angle sensor, if you will, to the flux of the motor, and get it calibrated, and then the rest of it's just kind of fine tuning.
Okay. All right, well, let's jump into one of our first questions here. I'm going to try and keep these ones pretty relevant to your EV and hybrid setup. So let's just get this first one up here. So the question is, how is the motor integrated in the powertrain? Does it replace the flywheel? Now, before we sort of jump into that, because those who haven't been following your build probably have no idea what we're talking about. So the 350Z that you've been developing for a long time now, you have just built, or had built, what I understand is about the most powerful VQ engine naturally aspirated anywhere in the world. I think you touched over 500 wheel horsepower. Is that correct?
Yeah, it made 530 on a really cold day, but it's more like 500 to be fair. Okay. So yeah, it's right here, so I can visually answer any questions too, if you guys want.
Yeah. So the key point here is that you've got this 500 horsepower naturally aspirated engine, but you're pretty greedy. That's not enough. So you've gone ahead and added a hybrid element here with an electric motor as well, which I understand is potentially in the vicinity of around about 200 horsepower. So that's getting to be pretty serious. But we want to talk about the integration here, which is really this question: how is that electric motor integrated in the powertrain, and specifically, does it replace the flywheel? So let's get this question out of the way so people can actually see.
Can you see?
Talk us through it.
That? Okay, so basically, if you look in there, there's an adapter that we've made for the block to the gearbox, and in here, where the clutch and flywheel would normally be, there's an electric motor mounted, and the rotor of the electric motor is effectively the flywheel now, and it's the hub that directly connects the engine to the motor and the input shaft to the transmission.
Right.
So basically the way it works is the motor is the starter. So there is no separate starter anymore. The motor needs to be able to move the car in first gear with no reduction. So it needs to be a high torque motor to be able to overcome, the lots of compression from the engine to get it spinning and to move the car forward. And yeah, that's it. And you get rid of all that clutch and flywheel and the hydraulics, and save some weight to pay for all the weight that's added from the hybrid.
All right, so getting rid of the clutch and the flywheel raises a few more questions about how you're actually managing the integration with this electric motor in terms of, obviously when you've got the engine just started up and you want to be in neutral and then going through the gear shifts, you've got a sequential gearbox behind it anyway, but paddle shifted from what I understand. So yeah, what are the sort of tricky parts around managing how that electric motor works?
Yeah, there's a lot of factors and controls in the ECU to make sure you can't destroy something. You know, you can't have the engine idling in neutral and then request an upshift, because that would just be really violent. So there's obviously the general controls around not letting the driver do something that could damage the drivetrain.
Yeah.
And then there's other controls on the keypad, for example. We'll have, if it's in neutral and you press the throttle, nothing will happen. It's not just going to free rev the electric motor. You have to arm the system and then hold the starter, and it'll crank just like a normal starter, for example.
Yeah.
Likewise, when you're stopped in gear, you have to press a button to allow the car to start driving. This way, if the car is accidentally on, say someone's beating the pedals at the racetrack and then the car just flies away, that wouldn't be very good.
Yeah, so there's a whole
there's
lot of things that you wouldn't need to even think about or contemplate with a conventional internal combustion engine.
Exactly, yeah. The thing about electric motors is they're so quiet, and the instantaneous torque, if the thing starts going when you're not expecting it, it's not like a gas car where you'll feel it and hear it a little bit and you can stop. It just goes.
Yeah, okay. Now, in terms of managing the shifts, with a paddle shifted gearbox, generally all we require is a bit of a torque interruption to allow the dogs to disengage and select the next gear. Obviously on the downshift, you need a throttle blip to match RPM so it's nice and smooth. So can you talk us through the interaction with those aspects using the electric motor?
Right now it's really simple. We're just doing everything through the gas engine, and just when there's an ignition cut, it cuts the motor and the motor just fades back in with the the recovery of the ignition cut. A little bit more delayed than that, but that's the general idea.
Sure.
But then running in fully EV mode, if you want to do gear shifts, that's going to need to be a factor, since obviously the gas engine is already off, so it can't provide any cuts or blips.
Yeah.
So in that case, what we've done is we've already done a kind of a torque request model with the engine. So with a little bit more fine tuning, it should be possible to just do the blips or the cuts, whether with the motor or the engine. It doesn't really matter, since it's just a torque request number that you're asking for, and both systems are calibrated.
Sure. The other thing that I want to just dive into here a little bit is regenerative sort of performance with the electric motor. How does that work? So basically you can actually recharge the motor while the car's running?
Yeah, so basically it's just like the motor, but kind of in reverse. You're using the motor to recover energy, and the limit generally is the battery. So
Sure.
usually when you're on the racetrack, you want to have the battery at a high state of charge. And that means that the voltage is very close to the maximum allowed voltage. So there's only so much current you can flow back into the battery before you start exceeding the safe voltage of the battery. So you'll see regen in any kind of racing is going to be limited by your state of charge. So as the battery goes down, you can get more regen. Really high-end racing series have batteries that are very high power, and the voltage doesn't change as much with current on very high power batteries. So you can, jam a ton of current into them, and you can draw a ton of current out. Unfortunately, we haven't gotten anything like that. We're just using a standard BMW i8 battery, which, like most streetcar batteries, it does have a fair bit of resistance. So there's only so much you can do there with regen.
Sure. I remember we did actually do an interview with you at, I think it was the PRI show back last year, and we talked a little bit more detail about this. And one of the interesting things that you mentioned during that interview was the way you are charging. From memory, you're charging the batteries up to, I think it was something like maybe 60 or 70% throttle. And then once you go above that, you start actually delivering power from the electric motor. Have I got that right, or am I sort of off on the wrong tangent?
Yeah, exactly. So we've got a trim knob on the steering wheel, and there's basically 10 positions. So the way it works is from 0 to 4, there was no charging of the battery. That's just power deployment. And 0 is nothing, and 4 will be the full power at full throttle. And everything in between, will blend with the engine. But there will never be any regen. So that would kind of be used in a case where the motor is getting hot or the batteries are getting hot. And you want power, but you don't want to, stress the system. Once you go above the next steps, it starts adding more engine power at partial throttle. So at 70%, it might add another 30 horsepower, but it'll apply 30 horsepower worth of regen into the battery. So the driver will still feel the same thing, but you'll have more chance to recover energy back into the battery.
Yeah, okay. No, that's really smart. All right, let's just jump in. We'll have a look at a couple of the other questions I just spotted in here. Let's go with this one here from Teeson, who's asked, how difficult is coding or tuning a hybrid and electric software compared to, say, a standalone? Now, I'm going to guess right now that might actually be a difficult question to answer because we haven't got access to a whole lot of standalones for hybrid or EV tuning, have we? You're kind of writing your own code, so you're in a bit of an unusual situation, but maybe you can talk to that question a little bit anyway.
Yeah, it's a totally different type of thing right now. Like you said, there is no standalone per se. You can't just go and plug something into an electric car. And electric motors are different in that gas-powered cars are tuned in a certain way for a reason to protect the engine or for emissions. With an electric car, there's not really the incentive from a manufacturer to detune the electric motor. So, in a lot of cases, you'll see a manufacturer putting in a small motor that they tune to kind of the limit because that's cheaper than putting in a bigger motor and leaving a buffer there. So as far as tuning an existing motor for a road car, it's kind of not, I don't think, going to be a big thing. And then for racing, all of the programming and coding is not that much different than M1 build for a gasoline powered application, but that's again not just generic standalone tuning type of thing.
So in a nutshell there, when we start seeing EVs really get a market share, and obviously people are already keen on modifying them, anytime you've got four wheels, probably most people want to make that car go faster regardless of what's powering it, so that there's not really going to be the potential for us in the aftermarket to actually make more power from most of the electric vehicles.
You could, for sure, but I think you'd have to change hardware. I don't think it's just a software thing. And the trouble, especially with Tesla vehicles, is that everything is integrated and there's over-the-air software updates. So it's really hard to keep the thing happy and going to superchargers and charging. For racing, but not so easy for road cars.
Yeah, okay. When we see aspects such as Tesla, you just mentioned the over-the-air software updates, and that's been a big part of what Tesla are doing. I know a little while ago there was a software update for, I think it was the Model 3, and from memory it gave an increase of something like 30 horsepower. So these owners of these cars sort of wake up one day and all of a sudden, for no cost at all, their car's got a little bit more power. So it's kind of a nice addition. Obviously, Tesla have got complete control over everything. It's their development. But what are they sort of doing to get another 30 horsepower? What are they changing?
So in that case, it was basically, from my understanding, it was a field-oriented control optimization. So basically, once you start to run out of voltage in the battery, to be able to make more power, you have to apply some current to weaken the magnetic field of the motor so that you can continue to have a difference of your battery kind of current needs to be able to go somewhere. When the voltage that the motor is making is equal to the voltage that your battery has, you can't flow any current anymore.
Sure.
So that's why you have to reduce the back EMF of the motor. And so basically what Tesla did is they optimized that, I think, beyond the state of the art, beyond what's kind of understood now by most inverter manufacturers, and they were able to effect more power on the motor because that process is more efficient.
Okay. All right, we'll grab another question here. I'll just get this one up from Scott Borg, who's asked, what's something about EVs or hybrids that's going to surprise people when they get popular? I don't even know if you've got an answer to that, but yeah, what can you tell us?
They're really fun on the racetrack.
That instant torque?
More so than you'd expect, yeah.
Yeah. Actually, on that note, though, I think it's probably worth just diving into a little bit the instantaneous control you've got with an electric motor versus an internal combustion engine in terms of the torque control. So, in particular, for the likes of traction control, reasonable to say that you're going to get much more accurate control of the available traction with an electric motor than an internal combustion motor?
Yeah, with a good inverter for sure. The Tesla traction control, you can almost not tell it's on. You know, there's the slip lights on a C1 on the dash we have. They flicker back and forth like between 2 and 4% like this. Like you can't even.
Okay.
Normally a car would shoot over and kind of do this a couple times, but with good control, it's insane. And the torque that you have, there's no gear shifts, there's no fumbling with trying to downshift coming into corners. So it actually makes it like optimizes a lot of things on the racetrack that are usually a problem.
Okay. Now, I've got another question that just popped up in the comments there. The question or comment was, doesn't that kill the battery life cycle? So I'm assuming, probably going back one question, we were talking about the likes of being able to get more power out of the Tesla. Yeah, can you talk to us about the sort of the considerations around battery life cycle? I know originally that's something that a lot of people were scared of with hybrids and electric vehicles, is the cost of replacing the batteries at some point if they do die.
Yeah, so the reality is that no one's changing batteries. Teslas go really long time with the factory battery, and it'll just decrease in capacity a bit. So you just won't quite be able to go as far after 5 or 6 years as you could when it was new. So generally speaking, what kills a battery is if it's really hot, or if it's stored at 100% charge for a really long period of time. Beating up on it on the racetrack is kind of okay as long as you don't overheat the battery. And most EVs will always reduce the power to protect themselves from overheating the battery.
Right. So, I mean, from the driver's perspective, nothing really to consider there. It's all automatically handled in the background. Yep. You're not going to damage anything. And when you say there that after 5 or 6 years, your battery capacity is going to be reduced slightly, and hence the distance you're going to be able to drive will also reduce. Can you maybe give us some idea? Are we talking like a 10% reduction or a 30% reduction? Or is it not quite that straightforward?
Yeah, I don't have the numbers in front of me, but it's around 10 to 15%.
Okay. Yeah, so it's still more than reasonable. Now, just moving on to your current focus with Mountain Pass Performance. So obviously you've got On Point Dyno, which is the tuning side of things, but yeah, you really embraced the Tesla in particular fairly early on with Mountain Pass Performance. So again, for those who aren't aware of that business, can you just give us a brief rundown on what you do there?
Yeah, so Mountain Pass Performance started after we had built the Lotus, and we kind of realized that there wasn't really a market for electric conversions. They're still quite expensive to do, but we really wanted to get into this industry of electric car tuning, and the Model 3 was coming out at that time, and it looked like a really kind of like an exciting sports sedan, like an M3 rival potentially. So we just started making suspension and brake parts for that car, and it's done well, and we've kind of set a few lap records with some modified Model 3s around the States and Canada, and really enjoy it.
So have you got an idea where you see that developing in the future? Are you going to expand into other types of electric vehicle? You've already really sort of touched on the fact that performance increases in terms of electric motor power is maybe not that simple, not that achievable. Yeah, what have you got planned there?
Right. I mean, we were thinking about the Porsche Taycan to do some parts for it, and any exciting electric car, I think we're interested in working on. So it's really just, there's got to be enough of a market there for it to make sense, right? I think the Tesla Model 3 group has been really great because those guys are all really passionate about the car, and they've all started going to the track and they really like it. So right now we're focusing on that car, and if there's some more take-hands coming out that people want to mess around with them, then maybe we'll do those cars as well.
So just basically see where the market develops and cover those that are proving to be popular.
Yeah, and none of these kind of compliance cars that are built just for emissions, and there's a bunch of these electric cars that aren't really a full effort from a manufacturer, so those
Sure.
ones kind of, yeah, who cares
All
about
right,
those?
we'll grab another question here. So let's bring this one up. So this one's from Testicles, who's asked, for the cost, was the extra 200 horsepower from the hybrid worth it compared to turbocharging?
Nope.
That's pretty brief and to the point. So you've basically done it as a personal challenge to see if it was possible, as opposed to being the cheapest or most cost-effective way of getting 200 horsepower more.
Yeah, it's a development project. There's nothing about money here where it would financially make sense. I mean, a supercharger would have been the most cost-effective way to go, but it helps our business. It helps what we do. It helps some of the services that we offer for other companies. Like, this is something that as a showcase, and then we end up getting jobs to do these types of things. So it's an investment more so than it. I mean, it might make the Z slower initially, even so.
So it's on that note. I mean, just for some perspective for those who are watching, could you give us a ballpark on sort of what you think that swap has cost on the 350?
So the main cost is the motor and the inverter. So that was about $25,000 US.
Damn.
The rest of the bits are, the battery was only $1,800 US. The rest of the bits is all fabrication and work. It's nothing different than the other stuff that we do.
But then there's also the amount of time that you need to consider for all of the integration development that you've done as well.
Sure. Yeah. I mean, I don't factor my time in. If you were to hire a company to do it, it would be whatever. It would be a lot. Just because it's not available yet, it's not a commercial product.
Yeah.
No different than if you were going to develop your own standalone for a gas-powered car, it would make no sense, but you can buy one for, a couple $1,000s. So we're just coming to the industry a bit early, and it's expensive when you do that.
Yeah, definitely. All right, we've got another question here I'll just bring up. So on a slightly technical angle, so from Fox Given, who's asked, why use a DC-DC converter instead of an alternator? Alternators are cheaper and simpler.
Main reason is just because the car is front heavy and we want to get the weight as far back as possible. Second reason is because if you're charging, if you've got a charger running, if you've got some other stuff going on, there's a lot of times you need to have the car stay powered up for a long period of time when the engine's not running.
Okay. All right, fair enough. Now, one of the other questions I just saw in there, I probably won't be able to grab it right now, but if you kind of gazed into your crystal ball and looked into what you think the future of motorsport is going to look like, how quickly are we likely to see electric vehicles sort of start to take over from internal combustion? Or are we still a long way off that?
My gut tells me we're still a long ways off. You're going to see it on road cars first. I mean, there's still carbureted cars from the 50s racing, all the time. I don't think they're going to go anywhere. Electric cars have their fair share of challenges, like from a safety aspect, there's some things, batteries are hard to put out when they're on fire, stuff like that. So,
sure.
But they're really fun, and I enjoy the different challenge of it. One of the things that I really don't like is this kind of spec racing where you just buy a car from a manufacturer for $500,000 and go racing. I kind of like that, everyone's trying to figure out how to make electric cars go fast, and that they have the potential to be really, really fast. So I think for a while yet you'll see them just in these little time attack and hill climb series, and then the next thing will be like a sedan short sprint racing series, which would be pretty cool to see.
Right now, if you take a production Tesla Model 3 for just an example, and you take it to your local racetrack with a fully charged battery, how long can you run that under like full 10 tenths attack out on a track before you're going to be a dead battery or flat? I don't say dead.
Uh, it really depends, but to not beat around the bush, probably about 35 minutes.
Okay, well, it's actually probably a hell of a lot longer than I'd expected. Obviously, then you've got to
Yeah, I
charge it
mean,
before you can go on another session, though.
no, normally we won't do that. Normally we'll run a 10 or 15-minute session, and the battery will go from 90% to 50,
Sure.
and then you just charge it back up. There's no point in running it down to zero.
Yeah. And in that 10 or 15-minute session, do you notice a reduction in performance over the session because of the thermal control functions kicking in, or is that not an issue over that sort of period of time?
Yeah, the thermals become a little bit of a factor, and also just as the battery charge goes down, you have less voltage, so as a result, you have less power.
Okay. All right, we've got a couple more questions in here, and this one you've kind of touched on, but we'll just try and sort of explain it anyway. So, Sasha, how do you tune the electric motor? Do you need to be on a track or transient dyno for that? So, again, you've already kind of touched on this, but maybe just to tie that up in a nice little bow, what can you tell us about that?
Yeah, so let's say you're going to tune a motor that you've never seen before. You first need to characterize it and get it to spin. So let's say you do all that work, and that's kind of the same as setting the ignition timing in a gas-powered car. Once you've kind of done all of that, you basically just need to figure out mostly just the phase angle of where you want to apply the current relative to where the motor is at. When you compare it to tuning a gas-powered car, fundamentally, it's much easier and simpler. You don't have variable camshafts and boost control and all this sort of thing. You just have really just one main variable to measure and control. And you can do it in a steady state environment on a dyno. The transients, there's no like Excel pump fueling or anything like that. It's just, putting the current in the right place to get the most out of the motor. So, I mean, I'm not super down that rabbit hole. I've only done a few motors, but so far it seems to be a lot simpler than tuning a gas-powered car from scratch.
Yeah, definitely. Once you've got those fundamentals covered, it definitely does sound like it's relatively straightforward. Not trying to overly simplify these things. Obviously, there's still a big learning curve, particularly for those just getting into it. Now, I'll bring up this question here as well from Get Nowhere Fast, who's asked, do you think electric conversions or augmentation like Kel's will be cost effective at some point? And obviously, you've just given us the sort of a broad idea of what that hybrid conversion on Kel's, your 350, has cost. Pretty substantial. Obviously, though, as the technology develops and we see more and more EVs out there, naturally we could expect the price point to come down. Is that reasonable?
Well, the Lotus is a good example. I mean, we at that time paid about $7,000 or $8,000 for the Tesla motor. They've come down now to $4,000, and that'll get you like 500 horsepower at the wheels. So
that's pretty reasonable.
Pretty cheap. I mean, I don't think you can get a 500 horsepower setup for as cheap as you can do like an electric conversion with 2 Chevrolet Volt batteries in the Tesla motor right now. It's just all the other stuff with the electronics and wiring and people not being sure about how it all works. But if it was just about money, it's probably the cheapest way to get 500 horsepower at the wheels reliably.
Probably another thing that I think is worth touching on there as well is, while I'm sure that an electric motor is not going to last forever, if you're looking at a 500 horsepower at the wheel electric motor conversion versus maybe taking a small capacity internal combustion engine, turbocharging it to get to the same power level, you've got to factor in that that's still going to be costly doing the turbo route. and then you've got an engine that is potentially going to need rebuilds over time. So there's not just the upfront cost of doing that sort of conversion, it's also the ongoing costs of maintenance and upkeep as well.
Yeah, you mostly just go through axles, but the main cost is electronics. People aren't used to spending $10,000 on electronics. You know, they'll buy manifolds and turbos and fuel rails and injectors, and they'll easily exceed that in all kinds of stuff you don't need with an electric conversion. But, you know, the electronics, naturally, there's a lot of advantages that you can have there. So people have to get used to thinking about things a little bit differently, because with the high voltage stuff, you have to have things in place to safely control it. You know, you don't want to get electrocuted because something's shorting out on the chassis and because you were too cheap to put something in that would tell you an isolation monitor is $400 or $500 and you didn't want to pay that to protect yourself. So, you know, there's things like this. The other thing that is a factor too with electric conversions is that everyone's kind of, I think from a manufacturer standpoint, like everyone's a little bit nervous to offer kits or anything, because if someone gets it wrong, there's a lot of ways you can hurt yourself.
Yeah.
So
yeah,
right now, yeah, it's kind of just been like you have to go and figure out how to do it on your own, because no one really wants to have that liability tied to them.
Yeah, okay. All right, we've got another question here from Nick, who's asked how are hybrid electric motors, or let's talk about the whole system in an EV, not just maybe hybrid, but how is the cooling handled?
So a lot of motors are just cooled with coolant, but high power motors have coolant and oil, and they put oil between the middle of the motor and the outside of the motor. And that really makes a big difference to help cool down the rotor. So you'll usually see motors that can go for a long time at high power are usually oil and water cooled.
Okay. So is that the oil and the water, is that then just pumped through a conventional heat exchanger, like a radiator, like we'd see on a normal car?
There's a lot of different systems. I mean, obviously in an EV, you're always trying to optimize everything. So just talking about just for road cars, they use the battery heat to heat the batteries, or sorry, the motor heat to heat the batteries, and they'll close off the radiators. So, you know, there's some other things going on there, but fundamentally on the racetrack, yes, it would just be going through heat exchangers.
Okay.
Road cars generally have a refrigerant system and with heat exchangers, and they'll use a refrigerant like an air conditioning evaporator on the oil loop to cool or heat the oil, for example.
Yeah. All right, we've got another question that's popped up here in the comments from Danny's World, who's asked, will hybrid sports cars start using axial flux over radial flux motors as seen in the Gamera?
It's just a packaging thing. I don't think from a cost standpoint it's a big deal. It's talking about how the motor is oriented, whether the rotor's like this or whether it's like this, and you know, whether the windings are around the outside of the motor or in front and behind the rotor. So it's just kind of like a boxer engine versus an inline engine thing. It's not really so much is one better than the other, I don't think.
Sure.
They both have their pros and cons.
Okay. Let's go with a question in here. We've got quite a few that have come through that maybe aren't so relevant to EV, but I mean, you're not a one-trick pony. You're definitely very experienced on gasoline-powered engines as well. So let's bring this one up. It's more of an engine building question, but we'll dive into it a bit here. So Brian's asked, can gas-ported pistons be used on a daily driven car, or is it for race use only? And maybe let's start by just explaining what a gas port on a piston is.
Yeah, well, gas ports are holes that are drilled in the top of the piston to help get some more ring seal. And I don't have a lot of experience, to be honest, to answer that question, to know. Pretty much all the engines I've built.
I'll answer that one then.
So yeah, you know better than I would, I think.
We used both lateral and vertical gas ports on our drag engines. And the vertical gas port, so what we need to understand as well is that the ring actually doesn't seal just with the radial tension that it applies to the bore. It's actually We want to get the combustion pressure down behind the ring, and that's what actually forces the ring out against the piston, the cylinder wall, and does the job of sealing. So the gas ports are just a way of getting that pressure straight in behind the ring. The problem with the vertical gas ports we find is that they tend to get blocked up with carbon, particularly if you're running on a gasoline-based fuel. We ran on methanol, and with our drag engines only running for very short periods of time, it wasn't an issue. The fuel runs really clean. So if you're running on gasoline-based fuel, vertical gas ports probably not the way. I wouldn't be going that route. However, the lateral gas ports which come in horizontally through the top of the ringland, they actually still do a pretty good job and don't tend to get clogged up. So yeah, I wouldn't be opposed to those, but vertical gas ports through the top, definitely going to not be the way for a street-driven car. All right, I think we might just about leave it there, Sasha. I've got through most of those questions on the EV stuff. So look, I really appreciate you taking some time out of your day to have a chat to us. Hopefully everyone who has been online has learned a little bit more about EV. And as I kind of touched on at the start, I mean, regardless what you currently think of electric vehicles, they are going to become more prominent. They are the future. We're not hiding under a rock. We know that's the way they're going to go. So we might as well embrace this technology and learn as much about it as we can. So I definitely applaud you for being at the front line of that, and definitely keen to see what your 350Z does once you get it back out on the track. And now also for all of our HPA 101 followers here on Instagram, to find out a little bit more about what Sasha is up to, make sure you follow his On Point Dyno and Mountain Pass performance profiles as well. That'll let you see what he's up to back home in Canada. So thanks a lot for your time there, Sasha. We'll look forward to catching you again soon.
It's always a good time talking, and thanks for kind of highlighting what we're working on here. And tell your viewers to go try and, you know, go for a drive in a Tesla. If you haven't been in one before, you kind of get a feel for the pros and cons.
Yeah, I must admit at this point, I still haven't had the opportunity to go for a drive in a Tesla. I would absolutely love to, just don't have a lot of friends locally who have gone down that route so far. But yeah, everyone that I know that's driven one or been in one, their mind has been blown. So yeah, look forward to that. All right, we'll leave it there. Thanks heaps for joining us, everyone.
Okay, take care. Good seeing you.